So, what up, lads? What up, lads? What up, lads? So we have So we'll be studying calculus today. Let me just Claude AI and brain-based calculus problems step by step. Alright, hold up. Before that, I think so we have this problem here. So the problem is for each part, express the result as a b fraction in lowest terms, where a and b are integers with a plus b given. So one is sine h ln 2 equals ab. So sine h ln 2 equals ab. And next one is cosine h ln 2 equals ab. So what it's basically saying is key definition. There are sine h x equals Let me wash my face. All right. So I actually don't give a. I mean, not don't give a like. I don't understand what the hell is going on. It's weird. So I'm gonna try to. So what I'm gonna do basically is just try to understand what the hell is going on here. Key definitions. So sine h and cos always that way. Explain. I'm new to this subject. Hyperbolic functions, where do they come from? Regular trigonometry functions, sine, cosine relate to a circle. Hyperbolic functions relate to a hyperbola. That's the only reason for the H suffix. Hyperbola. Don't let the name intimidate you. They're defined purely with E, Euler's number, 2.7718, blah, blah, blah. So sine hx, sine hyperbola equals sine hyperbola x equals ex minus e minus x. What the hell is my writing? Okay, so sine h x ex minus e minus x to cosine h, cosine hyperbola equals ex plus e minus x and 2. That's it. These are the definitions, not derived, just defined this way. What is e to the power of ln x, it equals x always. This is the real, always. This is the real foundation. In ln and e are inverses of each other. Like how squaring and square rooting cancel out. So e ln 2 equals 2, e ln 5 equals 5, e ln x equals x always. And for the negative, e minus ln 2, e minus ln 2 equals 2, eln times 2 to the power of minus 1 equals 1, 2, 1.5, 1.5, 1.5. Two. So basically, side the and ln will always cancel cleanly. That's why these problems are designed with inputs. ln inputs, it makes the arithmetic nice. Arithmetic. The only difference between sine h and cosine h. Look at the definition side by side. Bless me. So sine h, e to the power of x minus e to the power of minus x, e to the power of x plus e to the power of negative x, 1 minus 1 plus. That's the entire difference. So sine h subtract, you get a smaller value. Cosine h add, you get this larger value. Well, that's why sine h ln2 equals 3, 4, and cosine h ln2 equals 5, 4. Cosine h will always give a bigger result than sine h for the same input. Fusion check ln2 to 1, 2. Subtract this, which gives you divided by a half times 6, 3. Huh? I don't get it. I don't get it. So 3 minus 1/3 divided by 2, which gives you what? I don't get it. Oh boy, I don't get it. What do you mean? Huh? Negative ln2 equals e ln2 to the power, 1 e ln2 equals 1, because it equals to 1. Okay. So alright, I get it. Let's ask for more examples so I can practice. So E equals E ln 3 to 1, 3.5. I mean 1/3. Same goes for E negative ln 5. You change it into E 1 ln 1 E ln 5. How do you rate this? E just 1. One over E to the ln 5. 1 over all over. So 1 over E to the ln 5, which is 5 and 1. So back to the main question, main problem. So sine hyperbola is e to the power of x minus e to the power of negative x over 2, and cosine hyperbola equals e to the power of x plus e to the power of negative x over 2. So part 1 sine hyperbola ln 2. So sine hyperbola ln 2 equals e to the power of ln 2 minus e to the power of negative ln 2 over 2, which makes this 2 negative. So you would do minus ln 2 equals e to the power of negative ln 2, positive ln 2 over 1, which makes it a negative 1 and a half over 2, 1 half, right? Yeah, so 2 minus 2 and 1.5 over 2, which is equal to, make it 2, 4 minus 2, which makes it 2, which is 1, so 1.5. Oh, okay. Yeah. I multiplied it this by 2 as well, which was stupid. So that makes 3 over 2, right? Yeah, 3 over 2 over 2, which makes it 4 and 3. 3 and 4, 3 over 4, which makes it 3 over 4. So A equals 3 and B equals 4, meaning A plus B is 7. Part 2, cosine hyperbola. ln 2. So cosine hyperbola ln 2 equals e ln 2 plus e negative to the power of negative ln 2 over 2. Is this just definition? Yeah. Oh, so you just apply. Oh, okay. Cosine to the hyperbola. So this was x here. That's why you just apply the x into, okay, you just plug them in. I get it. So that makes it 2 plus, that is -2, which is +2 and 1, which is 2 and 1.5. 1/2. So 1/2 over 2, which makes it 4, 4. No. No. So it's just, yeah, the baseline should be 2, and 4 plus 1 equals 5/2 over 2. So we did the same thing, 4/5. So the same goes here. So A is 5 and B is 4. So we do A plus BA. Oh, so you did independently. I get it. So A plus BA, B. 20, 25, 25, 25 on B. Wait, hold up. I don't get it. The problem says to A plus A times B and B, which makes 3 plus 4 times 3 and B and 5 plus 4 times 5 and B, no? Huh? Wait, what? Am I any... Why am I tweaking, chat? Like, am I not understanding this? I don't fucking get it. So is it just 7 and 9? Ain't no way this is correct. What? Why? Wait, this is the most complex part of ever dealt with. Even I'm always things. How come? Means express the answer as A over B, where A and B are integers, then find A plus B. Great. Huh. Alright, whatever. That's not the main issue, is it? Problem number 2. Let me read it first. So cosine hyperbola equals ex plus e minus x to the 2, right? Yes, it is. So cosine hyperbola x equals 6 over 3. X is bigger than 0 when x is find the following values when x is bigger than 0, larger than 0, I should say. So sine hyperbola x, tangent hyperbola x. So cosine hyperbola x, so we can just plug these numbers in, I guess. And I guess this will hold up. So how do we convert negative? Was 1e6 3 6 over 3, which is which means I don't understand it. Okay, so key identity given cosine hyperbola x equals 6 over 3. Where did you get the 2? Can I please turn it off? Oh, all right. All right, so cosine hyperbola equals 2. Fine, okay. Just like the regular trig identity, trig identity, sine to the power of 2 plus cosine to the power of 2 equals 1. Hyperbolic functions have cosine hyperbola to the power of 2 times x minus sine hyperbola to the power of 2 times x equals 1. Interesting. So sine to the power of 2 plus cosine to the power of 2 equals 1. And therefore, cosine to cosine hyperbola to the power of 2 times x minus sine hyperbola to the power of 2 times x equals 1. This is the tool you use when you know cosine hyperbola need sine hyperbola. Part 1, sine hyperbola x. Cosine hyperbola times put to the power of x to the power of 2 times x minus sine hyperbola to the power of 2 times x equals 1. So which means we have cosine to the cosine hyperbola, which is 2. So 2 to the power of 2 minus sine hyperbola to the power of 2x equals 1, which makes it 4 minus sine hyperbola to the power of 2x equals 1, which is sine hyperbola to the power of 2x equals 3, because you put that you jump it negative minus 3 and you multiply negative on both sides. So which means sine hyperbola x equals plus minus 3 square of 3. All right, so since x is bigger than larger than 0, since x is larger than 0, and sine hyperbola is an increasing function, positive when x is positive. Oh, and since x is sine hyperbola x equals just 3. I mean, square 3. Part 2, tangent hyperbola x. Tangent hyperbola is defined as tangent hyperbola x equals sine hyperbola x over cosine hyperbola x, which means tangent hyperbola x equals square of 3 over 2. Summary, sine hyperbola x equals square root of 3, and tangent hyperbola x equals 3 square root of 3 to the power over 2. All right, I get it. So 2 and square root of 3. All right. So find, okay, hold on. Y equals sine hyperbola x to the power of 5 dy dx. dy dx. dy dx for y equals square root of sine hyperbola x to the square root to the power of 5. This is a chain rule problem with 3 layers. So identify the layers: layer 1, layer 2, and layer 3. So sine h, oops. So square root is layer 1. Layer 1 sine h is layer 2, and x to the power of 5 is layer 3. Derivatives you need: d over dx. What? Oh, okay. Oh, it's just derivative. I didn't know the first one. So when you derivative something inside the power, I mean square root, you get 1 over 2 times the number Okay, and you derivative sine hyperbola sine hyperbola u, the x, same thing, you get cosine hyperbola u, and you do derivative of x to the power 5, you get classic 5x to the power 4. So apply chain rule outside to inside. So we get what? 1, 2 times sine hyperbola to x power 5, because layer 1 was square root. So we do the same thing that we did here. And after that, you move to the second chain, and second layer, which is sine hyperbola. Sine hyperbola u equals to cosine hyperbola u. So which makes it 1 over 2 square root of cosine hyperbola to the power x times x to the power 5, and what? Oh, so you just multiply them? Huh. Hold up. So, okay. All right. No, I got this. I've got this. I understand. I understand the numbers. So you derivative this. So you do 3 times, 3 layers, chain rule. So you just multiply every single results you get. I actually get it. It makes much more sense because you do it one by one and just multiply them all together. Because they are one, they were one. This isn't the whole thing. Okay, I get it. I get it. Okay. So you derivative out layer first again. So sine hyperbola, I mean the no, not even sine hyperbola. So square root always goes square root 1 over 2 times square root of the inside values to the power 5 times the next one, sine hyperbola, is cosine hyperbola to the value inside, which is x to the power 5. And the last one, x to the power 5, which is 5 times x to the power 4, which makes here, oh, you just multiply. Okay, so 1 times cosine hyperbola times x to the power 5 is just the same, over 2 to the cosine, 2 to the square of sine hyperbola times x to the power of 5 times 5 times x to the power 4, which makes, oh, you just multiply them since you can't get the answer. So times cosine hyperbola x power 5, and you just write the same thing over down here. Okay. Now, derivative sine hyperbola u equals sine hyperbola u is just a rule you memorize, similar to how derivative sine u equals cosine u. Okay. So the answer is 5. No. Okay, let's try the first one. Okay. 5 times x to the power 4 times cosine h cosine hyperbola times x to the power of 5. Okay, to the 5, you get them all, and 2 times square root sine hyperbola x to the power of 5. All right, I get it. So we just keep on going. Problem. Find derivative. Wait, what's the difference between fx and dx? Are they both derivatives? Yes, both mean derivative. They are just different notation for the same thing. F prime of x just says the derivative of x. dy dx says derivative of y with respect to x. d dx f times x, same as both above, just more explicit. The reason two notations exist is historical. They were invented by different mathematicians. Leibniz invented dy dx. Lagrange invented f to the f prime x, and both stuck. Okay. So derivative of 2ln cosine hyperbola. So 2ln times cosine hyperbola 9x. So cosine hyperbola 9x. 2ln derivative. Oh, okay. So layers. Just ln's one layer. Cosine hyperbola is another layer. And 9x is third layer. So derivatives, you need derivative of ln equals the number 1 over the number. So basically ln 5 is just 1 5. ln 1 4 is, which is 1/3. ln, okay, I get it. Derivative of cosine hyperbola is sine hyperbola. Opposite of regular trig, no minus sign. And derivative of 9x is just 9. Huh, I didn't know that. Oh, okay. Apply chain rules. So derivative of 2 whole up. Wasn't it 2 ln? So they're two separate things. So hold up, how'd you do that? 2 times cosine hyperbola 9x. Okay, so oh, it's inside ln, which means so the entire thing's inside, which means they have to go ln just disappears, and okay, so that leaves 1 cosine hyperbola times 9x times 2, and that times cosine hyperbola 9x. I mean, derivative of cosine hyperbola 9x is sine hyperbola 9x times 9x, and the rest 9x, derivative of 9x is just 9. So you multiply this you basically just add them up. So what you get is sine hyperbola 9x times 9 over cosine hyperbola times 9x times 2 in the front, which makes up 18. But let me just see. Oh, wait, what? Did it say we should? Sine, okay, since sine a hyperbola over cosine hyperbola equals tangent hyperbola, and the values are the same, so you can just. But I wonder, 18 sine hyperbola 9x times 9x over cosine hyperbola 9x. Okay, so it still marks as correct, which makes sense, which I'm glad of. I'm very glad, but it doesn't mark as wrong. I can't change it, right? Yeah. All right. Press on. So we have limit L equals limit x is heading to 0, arc tangent times 3x over 6x, and we are looking for limit. Okay. So why you can't just plug in x equals 0, 0 over 0 is indeterminate, so you need L'Hopital's rule. Okay, so L'Hopital's rule, when you get 0 over 0, differentiate the top and bottom separately. So what we do here is L equals limit x is heading to 0, d dx arc tangent times 3x, and d dx 6x times 6x, which makes it derivatives. You just need a derivative both. So derivative of 6x, we just learned it, which is just 6, and derivative of arctangent 3 times 3x. Okay, so derivative of arctangent times x times with the value of u equals 1 over 1 plus value to the power of 2 without arctangent. Again, arctangent's derivative is 1 over 1 plus to the power of 1 plus u to the power of 2 times u. So derivative of arctangent with the value of 3x equals, oh, okay, so first, okay, I get it. So first you just 1 over 1 plus u, which is the value, which is 3x to the power of 2 times 3x, but it's derivative, so it's 3. So you just multiply it, 3, 1 plus 3x to the power of 2. Huh? No. I did something wrong. What is it? What is it? Or is it just 3x? How did you get 9 here when the derivative of 3x is just 3? So shouldn't I just multiply 3 to 1, which makes 3 over 1 plus 3x to the power of 2. Good catch. Let me clarify. The formula is where 1 over 1 plus to the value of 1 plus value to the power of 2, where u is 3x. So the value to the power of 2 equals 3x to the power of 2, which makes it 9x to the power of 2, not 3x to the power of 2. Oh, so you don't multiply after 1 over 1 plus u to the power of 2. Substitute, you don't multiply. Didn't he just multiply it? You just did. What you just did? What? Formula showed says the power 1 over 1 plus value to the power of 2 times the value of wait, bro. Okay, whatever, mate. I did understand. So basically, arctangent. Okay, I get it. Do I get it? Okay, hold up. Let me just do it again. So the value is arctangent 3x, and arctangent. If you derivative of arctangent is 1 over 1 plus the value, 1 plus the value, which is 3x, to the power of 2, which makes it 9x, 1 plus, yeah, times 3, which is 3, 1 plus 9x. And where the fuck did he get his power of 2 from? I'm so confused. Huh? So the value is 3x. Am I an idiot, chat? Huh? I don't get it. If the value is 3x and it's then it's 3x to or just 9x. Where did you get 9 from if there's only one power of 2 and you still leave it there? Oh my god, bro. Oh, bro. Yo, okay, alright, alright, alright. All fucking right. We are back in the line. Alright? Okay, it now clicks. It now makes much more sense. I'm a fucking idiot. I feel like I've been way too focused on this formula things, and my basic math function just stopped working for some reason. Okay. So basically, so you yes, 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 now it makes sense. Okay. And yes, derivative of 6x is just 6. So what are we doing again? Oh, so getting derivative of arctangent 3x. So this was the original question, and we did get the derivative of it, which is 3 over 1 plus 9x to the power of 2 and 6. So we basically, do I just multiply this? So 1 plus 9x the same and 18. Let me just try this out since I have 5 attempts. So 18 over 1 plus 9x to the power of 2. Okay, so what do we have more to go? Now plug in x equals 0. Oh, so here, you just need to plug in. Now, since it's limit, you plug in 0, which makes it, yeah, 0. So 1, 3 over 1, 6, 1, 6, 3, which is 1 and 1, yeah, 1 over 2. So 1 over 2. Okay. Love the feeling of getting right. So problem is given, okay, no, I need to read first. So double derivative 10 equals 100. Limit h is going 0. So f10, f times 10 plus h minus f times 10 minus f to the f prime 10 times h over h to the power of 2. All right, so what do we do here? Key idea, Taylor expansion. Near any point, you can approximate f as f, so is f times 10. What? Wait, f behave near a point, each term adds more precision. F, okay. F to the prime. What do you mean? I don't get it. It's a formula that says if you want to know the value of f slightly away from a point, you can approximate it using the derivatives at that point. Think of it this way. Imagine you're at position 10 and you step a tiny bit forward by h. So f, so what, okay, so the first one, f times 10 plus h is f times 10, where you start, plus f prime 10 times h plus f double prime 10 over 2 times h to the power of 2 the current value, how fast it's changing, how far you stepped. Uh, I kind of get it and not get it at the same time. I understand the last part, how I calculated, but I don't get this expansion, Taylor expansion. So this is just 2. Okay, let's just try it by myself. So basically that's just 2. On top here, he said, let's just say, given f prime 10 is 100, find that. So that's 100 times h minus f to the power f times 10 minus f10 plus k. So you times that. So f 10f plus f times h minus, so that's also 100 now, h minus h 100. Wait, what? So if you plug in h equals 0, you get 0/0, so you need another approach. The definition of f double prime, you already know f prime is the derivative of f. Well, f double prime is just derivative of f prime, and its definition using a limit is... Oh, what the hell, bro? Oh my god, bro. Leave me alone. Okay, so f double prime times a equals limit. Bunch of bullshit, and f prime itself is defined as blah blah blah. Since in the problem is essentially the second derivative definition is in disguise. Someone built for a fraction specifically, so when you work through it, it collapses to f double prime 10 or over 2. Expansion proves that those two things are equal. Think of it as a known result you can just use. So whenever you see this exact pattern, you just plug in. Whoa, what? But this fraction equation has the same as the formula. How did we get this? Huh. I don't get it. I don't get it, chat. Bro, I get it now. I get it now. So basically we have this. So in here, h goes to 0, and we have some bullshit going on here, minus f times 10 minus f prime 10 h. So you gotta know that whenever you see f times value plus, what was it again? F times, yeah, this one. So f times whatever the value comes, x plus y, let's say, it's equal to f a plus f prime. Like, how am I supposed to even memorize this, bro? Bro, like, how am I supposed to memorize this? Like, genuinely. Ain't gonna lie, bro. What are we that ass? I mean, at this point, it's not about math. Like genuinely, like none of this all about math. It's just about it's like, all right, now we are to the point where math doesn't fucking matter. So what we're gonna do is just tell me. Let's just say that whenever you see water bottle that's specifically 2 liters and has a blue cap, this equals to a what do you say? Oh, fuck, I can't even speak, eh? A toothpaste. This equals to toothpaste. Okay, you gotta memorize that. Whenever you see this, you gotta come up with a toothpaste or random bullshit toothpaste plus lip balm plus another water bottle, but it has to be Texas from Starbucks. Like, bro, what are we even doing? Like, give me some actual numbers, eh? Okay, whatever. So, whenever you see f times a plus h, I mean a plus h, yeah, equals to all this bullshit f times a plus f to the f prime a times h plus f double prime a over 2 times h power of 2. Where you should memorize this or else you're gonna fail the quiz. Like fucking bullshit, brother. Like, cause the calculation is just easy. Like now you have this. So what we do is, so basically f a 10 plus f prime 10 times h plus f double prime a to the power of 2 and times a. And now you have the same thing here, so you cancel it out. You have the same thing here as well. You cancel it out. So what you're left with basically is h to the power of 2 and f double prime times a 2 so you basically do the thingy 2h2 double prime a times wait what oh so you where did the h2 go? H to the power of 2. but still let the h2 of 2 go. Oh, okay. Oh, so you have hold on, hold on, hold on, hold on, hold on. So you have this. You cancel this out, and then you're just left with this. Since this is 100, and wait, what? No. Hold up. So hold up. Uh-huh. Yeah. So he. Okay. So you get that shit. You get that shit. No, I mean, so hold up. So this is on top of this. Basically, f10 plus f prime 10 times h plus f double prime times 10 to over 2 times h to the power of 2 is all above this. So you cancel it out. I get that part. Okay, fucking hell. Okay, I now get it. And this is 100, and this is 2, which is why the answer is 50. Okay. Oh, limit again. Actually, I might give this one give this one a crack by myself. So L equals limit x is heading to 0, x power of x plus 9x and to the power of 2 x and 2 over x. So what we do here is this is just x, this is just 9, and and so what do we do now? Chat. Do we just of course there shouldn't be an answer, but just wanna give it a crack, eh? Okay. Alright, no worries. We got my personal tutor here. So why it's tricky plugging in? Okay, yeah, I get it. So you actually I get it. So this is 0. So is it okay? Command doesn't work here. Okay, never mind. Okay, so let in L equals ln. Where'd you fucking get that from? Where'd you get that? Where'd you get that? No. Where'd you get that? Where'd you get that from? Where'd you? I mean, yeah, I fucking understand this, but where'd you get ln? There's no ln. No. ln. No. Again, where? There we go. You start with basics, eh? Don't overestimate me. I don't understand shit. Like you gotta start like from the baby steps, or else I won't understand. So we want to find L. Okay, the problem is that it has X in it, which makes it hot. So we use this fact. Ln and E are inverses, meaning E ln L equals L. What the fuck do you mean by that? So out of nowhere, just this just gets dropped. This niche and specific rule that E to the power of ln times L equals L. Hold up again. Wait, nothing changed. So wait, what? So if I see any problems with L equals, I can just get to create ln in front of because there nothing changed. What the fuck do you mean both sides? No, you did not do it on both sides. I don't see a damn ln and this part. Is so again, explain so we started off as L equals limit x is heading to 0, e to the power of x plus 9x to the power of 2 over x. And here we can't plug in a 0. I get it. You said it a million times. If there were such problems that you can just plug in 0, then they wouldn't even have made the problems, you know. So it's just fucking pointless. Even the kindergarten children would understand it. So take ln of both sides. Huh, since nothing changes when you, but okay, fuck's sake. So for some reason we just add ln to the both sides, even though it says nothing changes. But you know what? Nothing change. What also make nothing changes? Even if you add like 100 plus 100 on the both sides, multiply millions or billions to the both side, doesn't change the other both sides. So this cannot be an answer to why you should be adding ln, multiplying ln, specifically ln, to both sides. If that's your reasoning, like if this is your reasoning, just same thing as like, why do you like that? Because it makes me cool. It makes me look like cool. Why do you go to the gym? Because it makes me look cool. It makes me feel good about myself. But that can't be your problem, because anything can, because gym itself, like anything can make you feel good and make you feel like you're progressing in your life. But like that is not gym. It shouldn't be gym, because it can't be gym. I mean, like the reasoning is failing in fundamental sense, because if it's just all about being looking cool, feeling good about yourself, and it can be other things. It doesn't have to be gym. So you are lying. You are lying. I'm fuming right now. Step 3: bring the log roll. Okay, what the hell am I looking at right now, chat? Okay, so just bring it down. So ln L equals limit blah 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 bullshit, and we just put it down here, times ln ex plus 9x equals 2. Okay, yeah, 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 yeah. 2 times ln e to the power 9x, and x here equals to, where the fuck did ln go? Plug in zeros now here. Okay, 0 0 0. So use hospital. Derivative of it is okay. Hold up. I actually don't get this part. Where did you? The all right. Just give me all the information, all the formulas. That's just so niche and doesn't matter in real life at all. But it's gonna be so useful in this math, specifically in this kind of question specifically. So derivative of ln with its value next to it Wait, what? Was this just the number itself? Hold up. Oh, it's E. ELN. God, it's so. Oh my god, bro. Okay, whatever, mate. Whatever. Just fill me in. Fill me in if I'm missing something. All right, so derivative of ln and the value equals to the value. I mean the prime of the value over the value itself. So since we have, what is it? Since we have ln and this whole shit, which means the derivative of ex equals x. So x plus 9 above ex plus 9x. That's the derivative of it. Wow, how useful. What? That's the derivative ex. Oh, wow. Okay. Derivative of ex equals ex. Wow. It's just the same. Where this is true. It doesn't change when the so this is the only function in math where this is true. So other things are bullshit, but just this one specific thing is true. So and I should appreciate it, right? All right. Just fuck me up, eh? Just fuck me up a bit. So putting it together. Okay. I mean, yeah, ln disappears obviously, times 2, which is how we got here. You just multiply it to ex to e to the power of x plus 9, e to the power of x plus 9x, which if we plug in 0 now for some reason, it's going to be 9, 18, 0, 0. So, oh, okay, E0 equals 1, obviously. So 10, that's 20. Also here, this is 1. So it's 20, L, and don't forget your friend L. L equals 20. Oh, no. Okay, yeah. L, N, N, L, N, L, N, L. Oh, for fuck's sake. Oh, okay. At least thank you for summarizing it up, because I was about to ask you, like, just list it up so I can memorize them one day. I don't know, man. So derivative of ex is ex. It's just simple, eh? And derivative of ln x equals x prime x. Didn't? Derivative of ln is x prime x. Both are correct. They are the same rule. Wow. 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 So let's say you have ln5. So one way to solve it is to have it like what's derivative of 5? Okay, constant number. So derivative of x is 0. So you have 0 and 5, which is 0. And if you use another method, it goes. So if you have ln5, which derivative rule should I use? What this tells me that I should see specific one. Oh, so it's about letter. Wow. Okay. All right. ln u, which u is 2x plus 2 kind of thing. u 1 over x. We go derivative of sine x equals cosine x. I mean, these are easy, you know. These are basic ones. Cosine x, which is negative sine x. Derivative of sine hyperbola x equals cosine hyperbola x. Derivative of cosine hyperbola x equals sine hyperbola x, but this time without negative. Derivative of arc tan x equals 1 over 1 plus x to the power of 2. And power rule is derivative xn equals n times x. Yo, just oh, okay. Oh, all right. This one's just the most basic thing. Even a toddler will be able to do it. So we are looking for another derivative. What do we even call this one in English? Limit. We are looking for a limit. Okay. So we have limit. This is not even, yeah. So basically xe square to the power of negative x over 2. Now it's x times. I actually don't. Okay, it's the least one with least reported question. Okay, I for a second thought I hit the limit. So it's just x times e to the power of x x over negative x over 2. All right. So basically, what's the square? How did we do the square? Oh yeah, yeah, yeah. If it's negative, you put it down there and 1 over. So 1 over, you time it, so x squared here. Hospital row. Top derivative is, oh fuck's sake, okay, I almost forgot. So derivative of a square is 1 over 2 times the square. Okay, so, and bottom, very specific here. Huh. I mean, it's the same thing. So basically, so let's just start with the things that I understand. And the problem here is just fucking create one. Okay, just create it one. Create one for yourself. It's over 2. Which is, you multiply them together. I don't get this part. Okay. How long have I been studying for? Oh, 2 hours. Damn. Damn. So basically, yeah, we're gonna eat part. Okay. All right. That's it, guys. End of the stream, eh?